When you look at Malaysia's tropical rainforests on a clear, sunny day, the shallow rivers seem like the perfect place to relax. But these calm waters hide a fast-moving threat known locally as Kepala air, or a water surge. It strikes with almost zero warning. On July 17, 2026, a family was celebrating a child's birthday at Taman Rimba Sungai Sedim. In seconds, a surge swept through the picnic spot, drowning a 28-year-old woman and 2 young boys, including a 3-year-old. The local automated emergency sirens, designed specifically to warn visitors of an incoming wave, suffered a technical malfunction and remained completely silent. When mechanical infrastructure fails to provide a warning, survival depends on the situational awareness and environmental vigilance of the people on the riverbank. To understand how a surge happens, we have to look miles away from that sunny picnic spot, high up in the mountain headwaters. Heavy, localized torrential rain batters the mountain peaks. Down at the eco-resort, the sky might be totally clear, completely disconnecting visitors from the weather event happening above them. As water channels down narrow bottlenecks, it sweeps up debris. This diagram shows how it forms a natural dam, causing massive pressure to build behind the blockade. Eventually, the weight exceeds structural limits. The blockade ruptures, releasing the stored water downstream at once. What started as a localized mountain storm is now a kinetic weapon moving down the river channel at lethal velocity. As the water descends down, it accelerates. It absorbs massive tree trunks and heavy boulders along the way, weaponizing the flow into a solid wall of physical mass. You can see the destructive capability of this mass here. In June 2026, a debris-filled surge tore down mountain channels in Ulu Guruntum, hitting with enough force to completely collapse the main access bridge. These surges routinely cause secondary failures, too. In August 2024, a major surge at Slim River ruptured an upstream dam structure, stranding over 100 people across different campsites. The surges also leave permanent scars on the ecosystem. They strip vegetation away, causing severe soil erosion along high riverbanks and permanently altering the natural flow patterns of the riverbed. Because a Kepala air event is a high-speed avalanche of physical mass that destroys infrastructure, trying to endure it is impossible. Evasion is your only option. Let's return to the downstream picnic spot, right in the crucial moments before the wave hits. Since sirens can fail, you have to act as your own early warning sensor. First, you must watch the water color. If clear, pristine river water rapidly shifts to a turbulent, murky brown or tea color, the surge is already moving sediment toward you. Second, you must check the river's surface. Look for a sudden influx of white foam, dead leaves, twigs, and branches floating down the current. Third, you must listen to your surroundings. A surge pushes a massive volume of air and debris, creating a deep rumbling sound upstream that mimics thunder, low artillery, or a heavy train. Finally, the volumetric cue. This graph maps water depth over time during a surge. Counterintuitively, the water level will often take a sudden, steep drop, immediately followed by a nearly vertical spike in volume and current speed. Recognizing these 4 simultaneous anomalies gives you a critical, narrow window of just seconds to act before the main wave arrives. In those final seconds, the absolute first rule of evacuation is to drop everything. Do not waste a single moment trying to pack up picnic mats, coolers, footwear, or electronics. Leave it all. Next is your directional escape. Move strictly perpendicular to the current toward the nearest elevated zone. Never run downstream. If caught on a rock, establish a fixed anchor point immediately. Hold on to firmly rooted trees and refuse the urge to swim across. Shedding your material attachments and choosing the correct perpendicular escape route are the only variables you control when the water accelerates. Safety actually starts before you ever reach the water. Visitors must check MET Malaysia for weather forecasts in the upstream mountain district, rather than just looking at the sky over their specific destination. Authorities carry a systemic responsibility too. Automated early warning systems require mandatory, rigorous audits to ensure the alarms actually sound during an emergency, preventing the technical failures we saw at Sungai Sedim. Park operators must enforce mandatory closures of high-risk river parks during monsoon periods, and deploy trained community emergency response teams at known mountain bottlenecks. While infrastructure and trained rescuers offer a critical safety net, Knowing how to recognize the river's natural warning signs provides the essential lead time to reach high ground before the surge arrives.